In the last video, we studied the nomenclature and modification of restriction enzymes. Today, we will discuss the types and ends produced by restriction enzymes. There are 4 types of restriction enzymes known, but mainly 3 types are used in genetic engineering. Type 1. Type 1 restriction enzymes cleaves DNA up to 1000 base pair far away from the recognition sequence. Means the recognition and target sequence can never be same. It requires ATP, Mg2 plus and SAM, that is S-adenosine methionine, as cofactors, and examples of type 1 restriction enzymes are EcoK, EcoB, and many more. Whereas type 2 restriction enzymes recognizes and cut within specific sequence, means its recognition site and restriction site are same or very close to each other. That's why it is frequently used in genetic engineering, while type 1 and type 3 have only a limited role in genetic engineering. It requires only Mg2 plus as cofactor, and here separate enzymes acts for restriction and modification phenomenon. Examples for type 2 restriction enzymes are EcoR1, HIN2, etc. Now type 3. This type of restriction enzyme recognizes and methylates same sequence but cleaves 24 to 26 base pair away from the recognition sequence. It requires Mg2 plus ATP as cofactors. Example of type 3 restriction enzyme is EcoP1. Type 4, its recognition sequence is asymmetric. Cleavage occurs on one side of the recognition sequence and it is composed of 2 different enzyme cleavage sites and is up to 20 base pair away from recognition site. After cleavage, restriction enzyme produces 2 different types of ends, stick ends or blunt ends. What does it mean? Enzymes like EcoR1 produces stick ends. EcoR1 makes single-stranded break 4 bases apart in opposite strand of its target sequence, so generating fragments with 5' termini. In the similar way, some enzymes like PST1 produces fragments bearing 3' overhanging. The DNA fragments can associate by hydrogen bonding between overlapping 5' termini, or the fragments can circularize by intermolecular reaction. For this reason, the fragments are said to have sticky or cohesive ends. This type of cut is known as staggered cut. Enzymes like SAMA1 or HAE3 produces flush end, which is known as blunt end. These enzymes makes simple double-stranded cut in the middle of the recognition sequence, resulting in blunt end. This is all about restriction enzyme. Thank you for listening.